Okay, I will tell you about the staggering when we are designing the layout plans. Okay, but yeah, you should always keep in mind that in uninsulated it's 200 gap, and in insulated it is 500 gap. But when you go, I'm just comparing it. Okay, the gap will be always there in any railways you go. But when you go for UK rail or when you go for Canadian rail or some other rails, okay, XYZ rail. I'm telling about the UK rail, for example. Okay. So there, the gap, whether it is insulated or whether it is uninsulated, the gap will be always 460 mm. Okay.
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 But even in metro, it is the same thing. Only in Indian metro, if you go, it is the same thing because 200 and 500. But I'm just telling, just for your knowledge and purpose, I'm telling. So it can differ, right? It can differ from your client to client. Sistra, for example, Sistra is having a client in India. Sistra is having a client in Saudi. So both are different clients, right? Sistra have to adopt according to their client requirement. Let me know if I'm going wrong anywhere. So you have to adopt with that. It is just a parameter difference, okay? Nothing else. Conceptually, both are same. That's what I want to prove to you. So this is for uninsulated overlap. They will use this jumper. Of course, even in Saudi, it's going to, you're going to use this jumper. Even in India, whether it's in UK, they are going to use this continuity jump, which will be 2 meter parallel from of the contact wire. Okay, which will be in 4 meter length. They are going to use this for an uninsulated overlap. But for the insulated overlap, how it is? It's 500 difference. Why it is 500 difference? There is a reason behind it. Why? Why we are not keeping it 200 difference over here also?
Because one line
Why it is more?
is life, one line is life, one line is dead. So,
yeah, that is one of the reasons. Yeah, because when we open the isolator over here, as this is open, one line is live and this line is running behind, right? Like this. Okay, and one line is dead. Okay, at some point of time, they are together. One line will be dead and one line will be live. Okay, for that reason, the electrical, air is also an insulating medium, right? If you will keep it near, there will be an electromagnetic interference.
Yes.
Am I right, Ashwini?
Yes.
So even if this line is live and this line is dead, for example, and they are very close to each other, this, even if this is dead, there will be some electromagnetic interference will be there. And if some person is working even after 2 kilometers away, he might get electrocuted, right?
Yes.
On the maintenance. For that reason only we are making it dead. Okay. So that is one of the reason why we keep it more here. I hope so you understand what I'm saying.
Yes.
That's clear, yes.
So what happens here? So overlap, one line is getting end and new line is getting started. Okay. So how it will be? This is a very close picture for this one. Like when you are terminating the wire, you cannot terminate the wire at the contact wire level height. That is 5.6, 5.1 or 4.7, whatever the client requirement is there according to that. That height we cannot do. Definitely we have to raise it, raise the wire and then terminate. So how will you raise? This is called as a raise resistor arm. Okay, and this is called as a raise resistor clamp, RRC. Raise resistor arm clamp, RRA, raise resistor arm clamp. So this will be, this is the contact level height. Can you see this wire over here? This dropper is going down, right? And it's holding some wire. This is the contact wire. Okay, and from here, it will be raised to 500 Okay. It will be raised to 500 and above that 400 the catenary will be there for the wire which is going to get end or for the wire which is going to get started. I will show you the drawing. I know you are confused, but I will tell you through the drawing. Okay, but I'm just telling you now. Remember this one. Okay, in the
Okay.
overlap, this arrangement will be there.
Okay,
Okay,
from
there
contact
will be a
wire.
raised resistor arm for 500
Yeah.
and then for this one.
Yeah, from contact wire to the RRC, it's 500. This is what
Yeah.
you mean, okay?
Yeah. Yeah. So this is the contact wire. This is also a contact wire.
Mm-hmm.
But it is a contact wire of what? The wire which is going to get end.
Yeah.
Okay. I will take you to one of the drawing, RDSO drawing, it is called as. This is an approved RDSO drawing reference. Okay. So how it happens over here, we can see it. This is a straight wire, okay? Ashwini, are you able to follow me?
Yes, sir.
So here you can see the dotted line is getting started over here, okay? So at this position, it's coming. I'm coming to this position. This is the cantilever, okay? Just extend the lines. So this is the cantilever over here. And this is what holding the out of run wire. This is called as an out of run wire. This is in run wire. Wherever my pantograph is touching the wire, it is called as in run wire. So at this position, the wire is raised. Can you see here? This is raised, right? By 500 mm. It's now what picture I have showed you. You need to relate with that, okay? This is the contact wire I told, and it has been raised. This is the contact wire of the new wire. It's been raised by 500 mm. Okay, and this is by 900. Total will be 900 from this wire to the catenary. It will be 900. And the encumbrance for this wire cantilever, it will be 1.4. Okay, in metro it is 1.2 or 1.3. Fine.
So no idea.
I know, like 1.2 it is. I'm telling.
Okay.
Okay. It will be 1.2. Instead of 1.4, it will be 1.2. So yeah, so then it will be 250 raise and total it will be that much. Right? So it is like that. In UK rail, how it is, it's not 1.4. It is 1.3 over here, and they will raise for 250 mm. And here also accordingly, it will be 0.95. Zero, it will be there. So that much it will be raised. 10 comments. So the concept is same over here, that they do raise it before anchoring. That's what I want to explain you. Okay, they just cannot keep it over here and then terminate at this point. They cannot do that. The termination is variable, but it is always preferred for 7.06 meter from the rail level. Okay, so that they have to maintain it. So we raise it over here, but you see the contact wire how it is coming down over here, and this is where the 2-meter parallel run should be there. Okay.
What should be there?
2-meter parallel run of the new wire and the old wire should be there.
Okay.
Then only this overlap concept will come into the picture. Because in this 2-meter parallel run, my pantograph is going to leave this solid line and take up the dotted line. See here, further it is only the dotted line, right? And this wire is going to get terminated over here. That is the reason why you can see over here, this wire is also raised for 500 meter at this position.
Yes.
Can you see this? The dotted line is 500 meter at this 500 mm, sorry, not meter. Please forgive me. 500 mm. Are you getting my?
Yes. And then 900 mm, which wire is raised 900 mm.
900 mm is the catenary wire for this raised wire, but it is always measured from the contact level.
Okay.
That is making it 900 mm, or else it is 400 mm. From this contact wire, it is 400 mm. From this contact wire, it is 900 mm, because 500 mm will be the contact wire, 400 mm will be the catenary wire. So total it will become as 900 mm. Okay.
Okay.
Are you getting my point?
Yes, sir.
Fine. Staggering, I will tell you later, because definitely now if I will explain you, you are not going to grab it. Okay, because I know that you are in back of your mind, this is only going on now. Okay. I don't explain, I don't tell that staggering now. Right? Okay, so this is how it looks like from the front view, side view, you can say, and this is how it looks like from the top view. Okay. See at this point and this point, it will be same. And this is what? Insulated overlap. Okay. So just give a nice look into this. I'm going to ask you some question. I'm going to show another picture. Just give a nice look into this. You have only 2 seconds. No. Yes, your time is up.
Okay.
Yeah. This is uninsulated overlap. Concept is same over here also. 500 mm, 900 mm, same. But give a look over here. What is difference? Let me know.
Inner and outer.
No. It is a straight line. I am not considering any curve.
Okay.
Ashwini, you would like to give your try. Bilal has given a try. One try is given. Now it's your turn.
Here, jumper.
Yeah, 1 point you can say. Observation is very important, guys. The drawing. Yeah. 1 point is the jumper. Here, the jumper position you can see. This is called as an equalizing jumper, not a continuity jumper. Okay, potential equalizing jumper.
This is
The
called
name
a
itself.
F jumper, na?
Yes, this is called as an F jumper. Can you see this one?
Yes.
This is connected over here, not here. And at that location where it was connected.
Implantation difference is also there, na?
No.
Stagger.
Not implant. Stagger will be same, no problem. Stagger will be there because in uninsulated I told, right? Difference will be 500. And in insulated will be 200. That is there. Okay. So, but when you go on the site, you cannot see the stagger, right? What you can see is this jumper and this insulator. You have to find it on that itself. Am I right? Because you have to measure the stagger, then only you can come to know. Without measuring, I'm just saying, by just looking at it. Okay. This is what the jumper location is over here. The difference. And here the insulator is not there. You cannot find the insulator here, but here there is an insulator. Can you see the insulator over here? You can see the insulator over here. But in uninsulated, these insulators are not there. Only this insulator is there. And the jumper will be over here. That is called as a G jumper over there. Here it is called as an F jumper. Okay, this is standard everywhere, okay? All over the world. Getting my point, Vikas?
So this drawing is representing. I mean, what's the difference between two drawings? Each one is representing a different concept or what?
No, concepts are same, but this is insulated overlap. I told, no, the overlaps are of two types. Insulated and uninsulated. This is showing an insulated overlap. That's the reason why there are more insulator over here. Two extra insulator.
And the jumper, yes. Basically, yes.
Yeah.
Same as the lecture you provide. Yeah, as per the slide, yes. Type of jumper, yeah, and insulators.
Yeah. But here, the jumper is over here. The position of the jumper is here. And there is no insulator over here. The insulator will be only over here before anchoring. Because if I won't anchor, it will get earth. Okay, I need to insulate.
And also distance, one distance 2 mm and the other one is 5 mm, 500 mm, I mean. Right?
Yeah, 500 mm and this is 200 mm.
200 mm, yes. That's one of the difference. Okay.
You know how the jumper will look like if you are looking in this. So this is a jumper, it's just like this. But for this, how it looks. For this jumper, you can see it will be looking like this. F10. Okay. Define
this F shape, what we call it, F shape.
No, it is in a shape of S, but it is called as an F. Potential equalization.
Okay.
Because why it is S shape? Because it's holding the catenary wire of the in-running wire and the catenary wire of the outrun wire to the catenary contact wire of the outrun wire. So it will be holding in this way. Why it is been holding? See, I will have the insulator isolator over here, and this will help me to separate the wire. Okay, what I will do, I will take an isolator wire from here and I will put an isolator on that connection, and the another wire will go over here and touch it. If I will open, I will make sure that this wire after this insulator is dead. Okay. Am I right? Okay.
Yes.
And if this wire is dead, I will make sure that there is an insulator over here also, because this wire will be crossing the wire. So I don't want two wires into different potentials. I want them into same potential. That is the reason why this F jumper has been provided over here. So this will be good in seeing. I will provide an isolator over here. I will take a wire connection from here and I will supply towards this point. If I will open an isolator from here, this wire, my dotted wire after this insulator will be dead. Okay. I have to provide another insulator over here because you can see this wire is crossing this dead wire. And if this wire is alive, this wire you can get electromagnetic interference will be there and it can be live. It's not safe.
Yeah.
That is the reason why I have given here insulator and make sure that if this wire is live, this wire is also live. I cannot keep anything dead in India because in India, the copper is stolen. I cannot keep. The stealing will be also there. You cannot give the security in the remote location because train will be going from the remote location and it's a copper and it's a very costly material. In metros and all, we are using silver copper also. Silver is also a costly material. So that's the reason why we have to make it sure that it is potentially equal with this wire. That's what I want to say. That is the reason why it is called as potential equalizing jumper. Am I making sense to you guys?
Yes.
Okay.
Okay, guys. I think so. It has become too much for today.
Sir, one question.
Going on explaining. Yeah. Please,
Sir,
sir.
how does the direction of traffic d- affects the overlap, like upline and
First, tell me who told you to ask this question to me?
so I am facing that issue. That's why I'm asking. We have given the LOP to study, so in that the DDC has made the same kind of arrangement on both upline and downline. So
Okay. Can you see the direction of the traffic over there?
yes,
So the direction of the train is coming like this.
okay,
This is what in India we follow, but this is totally reversible when you go to European countries. Okay.
okay,
In India, you're working in India, so it's okay for you. You can follow this route. This is the direction of the traffic. So the wire should be open over here and close when it is in the trailing point.
okay,
Same here, the direction of the traffic you can see. Yeah, it is open. The mouth is open, the mouth is closed.
okay. I mean, where the new line, when the old line gets, like where the new line start, the mouth is open, right?
Yeah.
Okay.
Yeah. So did you get my answer?
Yes.
But in UK it is different. Okay. The direction of the traffic will be like this when this mouth is closed. It's
What?
just a rule they follow it. Okay. It's nothing like that. It's going to be fine only. We say like this, but they follow the rules that we have to set? No? Okay, in metro they might be following, but in Indian Railway they don't follow this rule. In new electrification they might follow, but in the old one they will not even follow this. There
And
are many.
what like if it is the same way both side, how will it affect the working?
It won't affect. It won't affect. Nothing is going to affect. It's just this things we are using this a rule. That's it. Right? Or if they might have written it somewhere. No, you have to follow like this only. No, it's just a rule that we are following. The basic design, what he said. Not going to affect you. Are you getting my point? Yeah?
Yes.
It's not going to affect you. How it's going to affect you? Can you say me? Like overlap is over here. This is raised. There will no be and nothing will be in the direction of the nothing will happen. Because imagine, no, we are telling like what for the single line. There are many single lines, no, in India. Single line train, there also they are running, no?
Yeah.
Am I right?
Yes. But
Konkan
in
railway is fully single line. Till now
yeah,
it is single line. But there also they are using this concept only. Is it happening anything? Nothing. It's just a rule they are following. That's it. Nothing else.
okay. So like the wire crossing and all that doesn't affect anything, right? It
No,
does.
no, no, nothing, nothing. You can imagine, no. There are single lines also, right?
Yeah.
Where up and down line work on the single line.
Okay. Yeah.
There also the overlap arrangement is same only. Only one this either this they will use or either this they will use.
But then that is in railways. In metros, so it is both. Metros there
No,
is no single line.
nothing like that. It's the same concept only. In metro also like this only overlap they will use. The same overlap. You want me to show you the Delhi Metro's drawings?
You have a begging plan. LOP.
Listen, So this is Delhi metro documents only. Yeah, I'll just show you how they do it. Can you see here?
Yes.
Arrangement is same only.
Uh,
Here it is crossing. Here it is open. Direction of the train you can see. In the crossing they have taken. Direction of the traffic you see. In the crossing they have taken. Okay. The metro they are using it in this way.
okay.
What is axle here? Axle is the mast or what?
It's just a name they have given. Intermediate axle means in the center.
Okay, and B, C, D, A represent what, those letters? I mean, name of the...
They have just named the mast A, B, C, D, E, F, G, H, I, J, K.
Yeah. Okay.